All right, let's check out topic 14, one-sided limits and limits at infinity. So let's consider the graph of 2 plus the square root of x and find some limits. So you should be able to do maybe that first one, or at least be able to draw the graph. So I do want you to look at this graphically. Hopefully you realize that the square root curve is just shifted up 2. So I don't have to draw a super accurate graph, but it would look something like this. So if you were asked for the overall limit as x approaches 0, as we've talked about, does the limit from the left and the limit from the right equal each other? And of course you're like, well, it doesn't even have a limit from the left, so how can the overall limit exist? So that does not exist. But if I just ask you, what about the limit? Okay, remember this one-sided limit, this notation, when you have the little plus here as that superscript, that's saying when I approach 0 from the right, you would certainly say that the answer was 2. So what I want you to be careful of, and sometimes what people miss, if you're not thinking and you're asked for this one, the limit as x goes to 0, and you do direct sub, you'd go, oh, that equals 0. Or the square root part equals 0, so the limit would equal 2. But you have to, the point I wanted to make is you do have to watch direct sub when the domain is not all reals, okay? So especially if you're at that point where the graph is kind of at the edge, you have to think about that and realize that, oh, I got to be careful with direct sub because I have to think of the graph and the fact that it's not even existent beyond to the left of 0, so I can't find both the limit from the left and then the overall limit. Now, for example 2, we've done questions like this. We actually made them harder because you were showing the overall limit or figuring that out the other day. So if they ask you just the one-sided limit, you just have to be careful that you are plugging in to the right spot. So on letter A, when it's asking for the limit as x goes from approaches 4 to the right, from the right, again, I don't necessarily draw the graph. I don't waste the time to draw the graph, but I think about which one I'm going to plug into. Well, if I'm coming in from the right, that's for values greater than 4, 4.001. So I have to look at this bottom one, and I would go 3 minus 4 squared, and I would get a limit of negative 13. So the limit from the left, the limit from the right would be negative 13. In letter B, when it asks from the limit from the left, left is less than, so I would have to look at this equation, and I know you can plug that in your head. 5 times 4 plus 2, I would get a limit of 22. So the overall limit, they didn't ask me, but of course that would be does not exist since the limit from the left and right are not the same. If they ask me the limit from the left of 7, that would be when x is less than 7. That still falls into this bottom equation. So 3 minus 7 squared, and my answer would be 3 minus 49, negative 46. And so I don't think that's a big deal. We've done piecewise, and you're good to go. If that would have asked the limit from the right, then I would put does not exist because the graph doesn't even exist there. So you could certainly get does not exist. But the ones we're going to really check out today are these guys. What if you have a one-sided limit? And we're going to explore these a little more than we did the other day. So if I plugged in 1, so I'm going to do the direct substitution over here because, again, I don't like putting equaling 0 over 0. So if I plug in 1, I go 1 minus 3 is going to be negative 2, and then 1 minus 1, that's going to be 0. Now, what we said the other day is that limit does not exist. Okay, and look, if the answer choices are all numbers and does not exist, then by all means, you put in does not exist. But sometimes the answer choices are more specific. Instead of does not exist, there's an answer choice of infinity or negative infinity. So I have to teach you, well, gosh, if you only learn does not exist and then you have to make the choice between the two, you're like, I don't know, I guess I'll guess. No, we're going to figure out how to get those exactly. Now, the thing of it is, there's two ways to do it. Okay, and I'm going to do two ways the first time, and then I'll tell you the way that I kind of prefer. One is to think of the graph. So remember these rational functions. What's going on graphically? What's happening at 1? Well, what's happening is a vertical asymptote. You have a VA. If I went and graphed this rational function, I would have a vertical asymptote. And so the reason, I hope you get that the reason why the answers are infinity or negative infinity as I approach 1 from the left is that this graph is going to hug that asymptote. I just have to figure out which way is it going. So again, I could get one option is to graph the rational function. I could go through those rational rules and remember about factoring and go, okay, this graph is going to have a 0 at 0 and at 3. I could kind of think of the EBA. It's bigger on top, so it's going to do something like this. It's going to graph like a linear. So that means my overall graph would have to kind of go like this, and this guy's going to shoot from up top, go to the 0, and then shoot that way. And if I do the graph, then my answer is very simple. I just kind of look at it. If I approach 1 from the left, I'm looking at to the left of that asymptote. Well, where is that guy headed? Well, he's headed to positive infinity, so that would be the answer that I pick. Now, option 2 is actually the one I like better, but you have to know when to use it, okay? And it's more an algebraic way of doing it, but to me it's faster than drawing the whole graph, especially when I just want to look at one thing. But if it's a simple rational function to graph, okay, fine. But I tend to do option 2 more. So I would still do the direct sub. I get a number over 0, a number other than 0 over 0. I go, okay, I know my answers are either infinity or negative infinity. Those are the only two possibilities. And what do? When I get a number over 0, and this is the only time I do this, okay, I'm just figuring out, is it infinity or negative infinity? Is it a positive number or a negative number? Now, here is the original question. Now, I do like it in factored form, so I do because I can plug in easier that way. I don't have to get the actual number, I just have to think positive or negative. Here's what I'm going to do. I am going to plug in a number close to 1, but from the left. So I have to think, what is a close number to a really close number, close to 1, but from the left? Its left is less than. So I'm thinking of 0.999. Okay? I'm going to plug into here and just figure out, is my answer positive or negative? And that's why I like it in factored form. 0.999 is positive. If I do 0.999 minus 3, that's going to be negative. If I do 0.99 for this x minus 1, that would be negative. Overall, what would you have? Well, if you have an odd number of negatives is going to be negative. Even number of negatives is going to be positive. So overall, this would be a positive answer. So you're like, okay, well, if it's positive, then it would have to be positive infinity. I just can plug in faster than drawing a whole graph, especially if it's complicated, and that's why I like that option. But you have to know you only do that option when you get a non-zero over 0. That is the green light to do that. You don't do it any other time. Okay? So let's look at example 4. Let's see what we have here. All right, so let's look at this next one. If I do direct sub, I'm going to get -7 on top. And then if I plug in on the bottom, -2 squared is 4. 4 times 2 is 8. 8 minus 2 minus 6, and that is 0. So I do get a non-zero over 0, remembering that that means that my two answers are either positive infinity or negative infinity, and let's pretend that those are my answer choices. So I don't see does not exist. Now you can, again, I do like factoring, so I'm going to change that to be the limit as x approaches -2 from the right. I have 2x minus 3. If I factor that bottom, and like I said, some people might do this from the beginning, and you would certainly see that you would get a number over 0. You would get 1 over 0. So yes, you can cancel that out. It makes your plugging in shorter, so I would do that. Now remember, this one's not a hard graph, so if you like graphically, by all means do it. I am going to do the algebraic way, just because for practice. I would say, okay, I'm approaching -2 from the right, so you think of a number line, -2 from the right is right here. So I'm going to plug in x being like -1.999 or something. Well, if I plugged in -1.999, I would have +2. That would be positive. So once again, I get positive infinity. We're like in the positive infinities here. Okay? All right. Let's look at the next example. Let's do my direct sub. And why don't you stop the video and actually try questions 5 and 6. I will say on 6 I actually do that one graphically because I just think of the cotangent graph. So why don't you try questions 5 and 6 on your own and then come back and watch. All right, hopefully on 5, when you did direct sub and you're plugging in -2 from the right, again, -2 plus 2 is 0, -2 squared minus 4, well, that's 4 minus 4. Oh, I get 0 over 0. Friends, when I get 0 over 0, that's not plugging in something close. That's the indeterminate form. I think back to, oh, when I have the indeterminate form, what are my steps? My steps there are going to be to factor and to do direct sub after I have kind of cleaned it up. So I factor, these cancel, and I have 1 over, I have the limit as x approaches -2 from the right of 1 over x minus 2. I do not put a close number to -2. Do not, from the right, do not put in the -0.19999 there. No, you only do that when you get a non-zero over 0. So even though this has the plus right there and you're approaching from the right, you are doing direct sub. And so you put in -2. So I have 1 over -2 minus 2, and my answer is -1/4. You have to know when you're plugging in that close number. And I know I've said it, but I'm just going to say it and emphasize it. It's only when you get non-zero over 0. When your choices are infinity or negative infinity, that's when you plug in that close number. But that is all. Example 6, again, I would do this one graphically because I do know what the graph of cotangent looks like. Remember, that graph does have an asymptote at pi, and the graph of cotangent kind of snakes through there and does this. So if you know that graph, this is a very easy question because it's asking me when I approach pi from the left, I'm looking at this left arrow. Well, where is that dude headed? He's headed down to negative infinity, and that's my answer. All right, so you have your choice of how you want to do it. Whether you do it graphically or algebraically is kind of up to you. But remember, they are going to be mixed in with things that are indeterminate or whatever the case may be. So on your homework, I do want you, don't just put, and you'll know this from the answer choices. I mean, there are some that are still going to be does not exist if they ask you an overall limit or something, but I want you to be specific. If it's a one-sided limit and they ask you for, I want you to say either infinity or negative infinity. Now, people always ask this, and this is, you can kind of add this in your notes. Let's say a question asks you for the overall limit as x approaches, I'll just do 0. I'll do a simple equation here. If I ask you the overall limit, well, if you think about that graph, when I approach 0, I've got one going up and one going down. Well, that's going to be does not exist. However, if I ask you the limit as x goes to 0, if I gave you 1 over x squared, where the asymptote is still at 0, but they're both doing this, I would put, again, infinity, because on both sides, I am going to the same thing. So remember, again, if they have the answer choices of does not exist, yes, you're going to put that. But if they have infinity and negative infinity and you have to choose, I would put this overall limit being infinity, because that tells me about the graph, that on both sides of that asymptote, I'm increasing without bound to infinity. And so it tells me I can visualize more what the graph is. If I just put does not exist, that could mean a lot of different things. So if they're asking you the overall limit, you can also, again, ask yourself, is the limit from the left and right the same thing? All right, we'll have fun taking limits. But we got to go on. Okay? This, limits at infinity. Okay, what's going on with limits as infinity, as x is going to infinity? So notice in this one, what's happening is that in all the problems we've done so far, right here, that says x goes to infinity. We've done x goes to 4, x goes to 7, x goes to negative 3, and you've never had infinity there. Think about what that is saying. What's going on when x is getting really, really, really big? On the graph, way out here, what's the graph doing? So hopefully you go, gosh, I feel like we've done that in pre-cal some. And what should you be thinking of? You should be thinking of either the horizontal asymptote or the slant asymptote. Is the graph leveling off? And if you were in my class last year, remember for an HA, we had a weird little saying that was what? I'll write it up here. Bobo Botten eats DC. Now, what did that tell you? It was asking you, if when we did the rational functions and the question was asking you about an HA, I said, okay, think of Bobo Botten. Now, what did that stand for? And you can write this down. So I'm underlining. I'm not going to write it, but you can write it on yours. Bigger on bottom, the HA was 0. Because remember, when you're looking for the HA or the slant asymptote, you only look at the highest powers. Because when x is a billion, the +2 is not going to do a whole lot. So it's only the highest powers that are really going to matter. So bigger on bottom, the HA was 0. Bigger on top, it had no HA. That's when it had a potential slant asymptote. The ends would be going to infinity or negative infinity. And then each DC stood for exponents are the same, then divide the coefficients. So if you had the same powers on top and bottom, highest powers, you divided the coefficients in front of them. Well, this is going to be how we do our limits because, friends, listen, is there an algebraic way to do these where you divide by the highest power and then you look at it? Yes, but this will always be on multiple choice. And I'm telling you, you want to do it in the fastest way. So when you see as x goes to infinity or x goes to negative infinity, I want you to think of Bobo Botten and do it very, very quickly. And these problems should take you a very short amount of time. So here's what I would do on this first one. The limit is x goes to infinity. Bobo Botten, let's look at the highest powers. My highest powers on top and bottom are squareds. What do I do when the exponents are the same? I divide the coefficients. So 3 divided by 2, my limit is going to be 3 divided by 2. Done. That's as long as it takes me. Because that graph is leveling off at 3/2. So the limit as x goes to infinity way out here, that limit is 3/2. Would it be any different if I would have changed that problem, and I'll just write f of x, I'm not going to copy that whole equation down. Would it be any different had it said x going to negative infinity? Or would I get the same limit? Well, I'd get the same limit because way over here, whatever the graph is doing, he's going to level off at 3/2 as well, so there would be no difference. All right, you look at example 8. What do you think about him? Boom. I mean, that's about how long it should take you. X goes to negative infinity, bigger power on bottom. I have x on top. I have 2x squared on bottom. Bigger on bottom. The HA is 0, so my limit would be 0. And in the same way, if this had been x goes to infinity, I would also have gotten 0 as well. So when you have an HA, whether you're taking the limit as negative infinity or x goes to positive infinity, you're getting the exact same thing. Now let's move on to these last guys. All right, the limit is x goes to negative infinity of all that. Well, here's what you got. You have the higher power on top, so that's kind of the bottom part. Bigger on top, n. N stands for no HA. So what you have to realize, friends, when you're doing the bottom, once again, that limit does not exist. But if they're more specific, we have to figure out, is it infinity or negative infinity? If they're more specific and have those choices, then you have to, which is I want you to do on your homework and on your test, they'll be specific like that. I want you to figure out which one it is. Now remember in pre-cal when you had a higher power on top, we had to do long division. And I know right now you are so excited because you absolutely loved long division. Well, I hate to burst your bubble, but I'm not going to do that much work because it's pointless to do that much work. I don't care if the asymptote, if it's slant, is x plus 2 or x minus 5 or 2x minus 7. I don't care really what it's doing. The point is at the ends, I already know what it's doing. So here's what I want you to do when you have the button, when you have a higher power on top. You look at the highest powers. I have 3x to the 4th over 2x squared. You do have to look at the numbers because you need to reduce this. This is reduced to 3/2 x squared. Now, I don't really care that it's 3/2. The point is that it's a positive x squared. That means we didn't even do this type of asymptotes. You actually don't have a slant asymptote, you have a quadratic one. If you kind of drew that out, a positive x squared, that means it's going to look like that. So if I were drawing the rational functions, on this side it's going to head this way wherever it's going, and this side somehow is going to go this way. Now look, the limit as x goes to negative infinity, well, where is this arrow going? It's going to positive infinity, so I put positive infinity. I'm sorry, yeah, that was negative infinity, rather. As x goes to negative infinity, I get positive infinity. On this question, it's asking, where is the right-hand arrow going? Well, he's also going to infinity. So the bigger on top, it takes a little more work, but it's not, you don't have to do long division. You do have to be careful though, because people, it very much looks like, okay, in every question you've said, whatever I got for negative infinity, I get the same thing for positive infinity. So I don't really care. Well, let's look at this last example. In this last example, notice that I do have a bigger on top. So I have the higher power on top. So I have to think about looking at copying the highest power on top and bottom and reducing. So when I reduce, I get negative 3x. There's my slant asymptote, a general shape of it. Okay, I'm not going to do long division. I just go, okay. If I ask you to draw me negative 3x, you would draw it this way. That's what you would draw. And so, someone's at my door. So as x goes to negative infinity, you have to look at this arrow, which is infinity. When x is going to positive infinity, you have to look here, and that's negative infinity. Sorry, the dog is just going to be barking.